private astronaut missions that we do today are just building blocks to ultimately building and owning and operating our Axiom Station.
The effect that people have gone to space and had is called the overview effect. Many people have come back profoundly changed because of their experience. And I think the more people that we can have that see the world as the whole world, the better off we all are.
Welcome everyone to this new edition of our holographic podcast or HoloChat. Today I have a very special guest, Christian, and I'm also in a very special place. And he's here as a hologram, but we are here at Axiom Space. Christian, welcome to our show.
Thank you. Thank you for having me.
Well, Christian, a lot of people may be aware of Axiom Space. This podcast goes globally, but some people may not be so familiar with this beautiful and huge company in Houston. Please tell us, what is Axiom Space?
Well, Axiom is a company that was formed in 2016 to really move humanity off the planet. We have a vision of living and working off the planet with hundreds, if not thousands of people living off the planet, living and working in space. And the emphasis there is really about working. We're trying to build the infrastructure that actually supports development of a human-based low Earth orbit economy that really allows people to drive revenue, drive business, drive opportunities in low Earth orbit.
You mentioned something important, very important, drive business. This technology, the technology that we are using today, it flew to the space station, and the first two-way holographic teleportation in human history happened during Axiom 1 mission. So I don't know if you want to mention something about that.
Sure. We had the opportunity to fly. Well, let me back up. One of the things that we do as we're building the next generation space station is flying private astronaut missions to the International Space Station. On our first mission, AX-1, we had 3 private citizen customers that flew to the space station. One of those customers was a gentleman by the name of Mark Pappy. He's a Canadian entrepreneur and investor, and he partnered with your company and a number of other entities in Canada together to put together a 2-way holoportation project, which was the first of its kind in space. We've had many VR and AR related technologies that have gone to orbit, but this is the first time we've had a telepresence or a holographic presence, so to speak, of a crew member from space to someone on the ground, and that same person on the ground presenting themselves fully as a hologram on orbit. It's a unique tech, one that we wanted to test because we see a future for it in the idea that future space stations and future space infrastructure can benefit from communication methods like this, where 2 people can be essentially in the presence of each other having a normal conversation.
Fascinating. Now, you mentioned Axiom 1, now is AX3 mission, and I believe that you are aiming for a AX4 mission, but it's not only flying people, it's learning. I believe that you are building your own space station, the Axiom Space Station. Is that right? And if so, can you elaborate on that one, please?
Sure. So the private astronaut missions that we do today are just building blocks to ultimately building and owning and operating our Axiom Station. That station is already in construction. Our partner Holographic is building our pressure shells right now in Torino, Italy, and they'll be shipped over here to Houston, Texas in the near future for assembly and integration, which is when we'll put all the stuff that goes inside the space station on the inside of it, seal it up and put it and send it to the launch site to launch to the International Space Station, where we're going to attach our space station module by module off the front of the existing ISS. And we'll stay there until such time that the ISS is ready to be retired, and at that point, we'll be ready to separate and become an independent platform and continue the good work that's been done on the space station to date. The private astronaut missions that we do are practice, so to speak, for us in order to learn all the operations, the training, and all of the techniques and tools and capabilities that we need to work well with NASA, so that ultimately when we're attached to the space station, we are good partners together. In addition to that, those private astronaut missions allow us to start flying new customers to the space and new customers that haven't had access to space previously, but it also enables us to do a whole host of what I would call earlier precursor research that we will see grow into research programs on our space station platform when we're ready.
Wow, that's amazing. So now you are building the blocks just for space commercialization, the first private commercial space station. And also you are flying astronauts, but also there's some, as I remember, research opportunities for companies. There are more than that. So first of all, let's say you have a company that is watching this podcast. If they want to participate either in research or either they want to fly to the station, either the space station, the ISS, or your space station, what they need to do?
Well, today, if a company wanted to fly to space, they can do so with Axiom, and they can go either to the International Space Station today or to Axiom Station tomorrow. We have good relationships with NASA and the ISS National Lab, which means that we can put projects into space and on the space station today. And those projects can ultimately, whether they stay on the ISS or come home after a short stay, they could go back or go across the hatch to the Axiom Station once we attach our Axiom Station in late 2026. And so companies can bring any kind of project to space. It could be a research project where they're trying to answer a question where microgravity becomes the way that they illustrate a new phenomenon or understand behavior of a certain system. Or more importantly, and perhaps more interesting to corporate America or the international corporations of the world, would be the idea of using microgravity as an environment to do in-space manufacturing, using that unique environment where convection and sedimentation and all of the physics associated with gravity change, and that it would allow new manufacturing processes to occur and potentially make new products that you can't make on Earth.
Wow. Well, I read last week, you are one of the fastest growing space companies globally. You are developing a lot of capabilities from scratch, like flying astronauts, building your space station. But as I remember, you also have a facility here at the spaceport, and you will build or assemble your space station here at the spaceport Houston. Is that right?
Yep, that's exactly right. We had the city of Houston and Axiom collaborated, and the city built us a manufacturing facility out at the new Houston spaceport at Ellington Field. That building has been finished, and we have taken occupancy of it in late December. We had a ribbon-cutting ceremony with the mayor just before he left office. And that is the location where we're going to be assembling all of our spacecraft. As I said before, we are building the pressure shells for our space station with a vendor, Thales Alenia in Italy, but those will be shipped over here on an airplane, land at Ellington Field, roll across the tarmac over to our facility and into our manufacturing facility, where we will put all of the insides into the systems that are going to operate the space station, and we'll put them inside the module itself. And the pressure shell is obviously just a cylinder. It's just a structure made of metal. You have to fill it with all the plumbing and the pipes and the wiring so that you can use this space station for communication, so that it can fly itself to where it needs to go, where it can keep the crew alive. And all of those systems kind of have to be put into that module like a ship in a bottle. Surprisingly, even though Houston's been the home of human spaceflight for over 50 years, there has never actually been a human-rated spacecraft built in Houston. They've always been built elsewhere. So Axiom Station is actually going to be the first human-rated spacecraft built in Houston.
Wow, that's great. Christian, this is one of the first holographic interviews, holographic podcast. People will be watching this in 20, 30 years from now as one of the first holographic interviews. And hopefully I'm right, this is your first holographic interview. This is going to be a two questions. The first one is, how do you see the company in 20 or 30 years from now? And the second part is, what do you want to say to the people that will be watching this holographic podcast in 20 or 30 years from now?
Well, where I see Axiom 20 or 30 years from now is building the first cities in space. Again, what we'd really like to do is drive the economic reasons, the markets for being in space. And that need for space will drive the need to put more people into space. And when you put more people into space, suddenly you're going to need a whole ecosystem to support those people. Not just a space station that's meant to keep someone alive and help them do their research, but you need hospitals, you need clinics, you need diners, you need sanitation facilities, you need power facilities, you need all of the things that you see around you in a normal city. And all of that infrastructure is something that Axiom ultimately hopes to provide or partner with to provide with other collaborators. And so for us, 20 or 30 years from now, we would ideally see hundreds, if not thousands, of people living and working in space on large infrastructure in low Earth orbit and beyond low Earth orbit as well. Because as you probably are aware, even cislunar and the lunar environment is starting to get commercialized. And so we could talk about capabilities, facilities, accommodations on the moon, and perhaps even further out into the solar system.
So we're going to be an interplanetary species at some point, and hopefully very soon, and hopefully I will be able to see it and the people watching that today. And there is a common question. Why should we invest in space? Why are we taking this huge effort in commercialize not only low orbit, but also the moon and eventually other planets like Mars?
Well, there's a couple different arguments for that, and it really depends on which one kind of resonates with you the most. The first is obviously the exploration argument. We should go and explore the solar system and put humanity as far out and understand as much as the solar system as we can, and maybe even further someday. But I prefer a more economic-based reality, which is space is somewhat like the internet of 20 or 30 years ago. It is an environment and an ecosystem that is pretty much untapped for its economic opportunity. And I think what we're going to find is that space is a very valuable asset and a very valuable environment to do things in. And whether that's in low Earth orbit around our planet, or whether that's around the moon, or whether it's around another planet, I think there are opportunities to create and to do in a way that drives economic return. Now, that doesn't even count the things that you can, quote unquote, harvest from space, whether it be an asteroid or the moon's surface or the Mars surface, in terms of resources and other things that perhaps are becoming more and more limited on Earth, but could be harvested from Earth and space over time. And so in order to get to that future state, you need to have infrastructure in space today that allows you to practice doing a lot of those things. And by practicing and finalizing and fine-tuning all of that technology, we get to that future where we're using resources from space, where we're recycling things in space, and where we're ultimately driving economic return and profit from all of the activities that we have in orbit, which then helps the economies of any country that's exercising all of that in space.
Wow. Well, it sounds like science fiction, but it is real and it's happening right here. It is. And you're making that happen at your company. So this podcast or holocast or holochat, people will be interested to be part. And now you open this globally. Anyone, I believe, from any part of this planet, they can join, right, to perform research, or they can send experiments to fly on a station, or they can apply to be astronauts. What else can companies or researchers can do?
Well, in terms of who can access space, that's the beauty of commercial platforms like Axiom Station, because today the International Space Station is limited in its partnership to the partner countries that have made up a consortium that has actually built the space station, and they're the ones that get access to and are able to use those resources and get access to space. Simply by enabling things like private astronaut missions alone, we have been able to welcome more nations to the space station than have ever had access before. Now with the space station that we're building, we can invite a larger population of the world in terms of countries and companies to use space to differentiate their economy or to drive research that's important to their mission strategically. And there are many things that you can do in orbit that the International Space Station has fostered a rich environment in microgravity research. But that research has been focused primarily not so much on applied research, but more fundamental questions. How do we keep humans happy and healthy in space? What is the space environment like? what do we see out there in space that's important for the future and for exploration? Now we have an opportunity with commercial platforms to really get into applied research, answering questions like, how can I make space valuable for me? And there's a couple different there are a couple different markets that we think are untapped. One is the commercial research market, or actually using space for an industrialized research process. I'll give you an example. If you wanted to crystallize proteins in space that are important to human health, sometimes space provides a very ideal environment to crystallize better proteins, which makes you better understand their structure, which then helps you figure out how to make drugs to interact with those proteins. So you can use space as an industrial research opportunity to study and clarify those kinds of proteins, especially membrane proteins in cells, that you want to interact with drugs to do different things in the human body. That creates value for pharma and biotech immediately. There is in-space manufacturing opportunities where you use the microgravity environment to make things. Recently, there was a company that has pulled 5 kilometers of specialty glass fiber optics in space. The reason that's important is because they can pull a more flawless glass with less defects, with more doping that allows them to communicate much more data across the same cross-sectional area of fiber. And when you can do that, you can create fibers that create massive amounts of data compared to traditional fiber. It's just one example, an application where microgravity has fostered a new product that can be manufactured. On the medical side, you can make things like artificial retinas, where you combine light-sensing protein and polymers together in a layer-by-layer deposition methodology that you can only achieve in space today, to create a superior product that can be implanted in the retina on the back of your eye and ultimately address diseases like macular degeneration. And so these are just a couple applications that are real, happening right now, that are in the in-space manufacturing environment, and both are using the physics of space basically to create something that can't be created on Earth. Now, the other application with manufacturing is making things in space for space. We're cursed today by having to cram everything that we want to get into orbit inside and underneath the rocket nose cone or fairing of a rocket. But if you could make something in space, you can take that raw material to orbit, make super large structures that don't have to survive launch. You can do that in orbit. And so in-space assembly and manufacturing is another application that is really interesting for the future as well. And space stations like Axiom Station can be a platform, again, to prove many of those technologies and perhaps even make some of those products that end up getting sent to different parts of the solar system. The other opportunity that's pretty much unexplored on government platforms to date is the idea of using space as marketing or media opportunities, shooting a movie in space, playing a sport in space, creating an advertisement in space. Space is a really attractive and interesting thing to a lot of the world's general public. If you can capture their imagination with something that you can create in space, you can create a lot of value or create a very powerful message depending on what you're trying to do in orbit. So those are just a couple different avenues that I think we're planning to explore today, and we're trying to leverage our early missions to this International Space Station to do as quickly as possible.
Wow. So why this Axiom Space Station is different from the current ISS?
So the ISS is a big complex project that hadn't ever been conceived before. And part of the problem is that the ISS was a super expensive project by the nature of getting all these partners to collaborate and agree and building a fairly complex, some arguably say the most complex engineering project the world has ever seen. And because of that, it really was expensive. Axiom really believes that we can build our space station for probably 1/100th of what the actual International Space Station would cost to build. Now that we get the benefit of all of the learnings that we got from the International Space Station to make smart decisions about what really needs to be built the same way and what can be built differently. And let me give you an example. The flight computers in the space station are built with older technology. They take up large amounts of volume, and volume is certainly valuable in space from a real estate perspective. And they cost roughly $1 million to fix or replace. But today, Axiom is borrowing computers that have been designed and driven to mass marketing and mass production through the electric car industry. And the same boards and computers that run the code in electric cars are the same kinds of tools and computers that we can use on Axiom Station. So now we can build a fully flight certified flight computer for $10,000. And when you can when you can scale down costs like that, you can build something for a tremendously less amount of money. And you have all the durability and reliability that's been built into the industry that's building those boards, that you know you can count on the reliability. Then you make smart decisions like making that your flight computer for every computer in your space station. So rather than different computers to run life support and other computers to fly the space station, you use the same computer all over the place. And so if the one flying the space station breaks, well, you pull one controlling your water dispenser out and you reprogram it and you go put it on its way to flying the space station. And that massive redundancy helps lower cost and risk as well.
Wow, this has been a great interview. Christian, is there something else that you want to add to conclude this interview?
I just hope that when we look at the future of space 20 or 30 years from now, we see Axiom providing infrastructure all over the solar system. And it's built on what we're providing today, which is new access to space that hasn't been available before. If we can create new reasons to be in space, we can create reasons to keep people in space. And if we create reasons to keep people in space, it creates reasons to build more infrastructure and to do more things in orbit. And we really believe in our future and our vision that is where we're going to end up one day. And so my dream is always that 20 or 30 years from now, when the first of the space archaeologists are actually digging through some of the debris that's being recycled through technology that we have developed on the Axiom Station, they find some of these early piece parts with Axiom logos on it and recognize that Axiom was the cornerstone or the pedestal or the foundation by which all of this space economy was built. We really want to provide universal access to space, and we want to do that for all of the countries and individuals that want access to space to do something meaningful. And so we're hoping that we can do that today to create that future for tomorrow. Amazing,
great interview. Thank you so much for being my guest. Thank you so much for being here as a hologram. But I believe this is growing exponentially. This company is literally taking off. So Christian, thank you so much for being here again. And hopefully all of you just can subscribe, watch it, and learn more about Axiom Space, one of the best companies. And I believe that pretty soon we can say that it's going to be the top company in space exploration and colonization. Thank you for watching.
We are building the world's first commercial space station, one element at a time.
We think that what we're doing is for everyone, everywhere. This is a global endeavor. Our partner, Thalasalenia in Italy, is in the finishing stages of building the first module, the first pressure vessel.
We are here in the integration and manufacturing area of Thalasalenia Space. Here we have the two cones that will be part of the module. Is also the gate to the module to come in and to come out. The very big cylinder that will be the core of the module. Just to have an idea of the dimension of the real module, you can see me compared with the structure. On these ports, all the additional modules will be docked. This is the most complex piece of the entire Axiom module.
We're on pace to build a human-rated spaceship faster than anyone's ever built one.
When we look at our roadmap, we look to see how we can double its capability every 5 years.
It requires a lot of different talents and a lot of different engineering backgrounds, so we've really expanded the team.
I'm working on the time-sensitive network aspect of the space station. So that's the network, have all the flight computers synchronize and actually do the thruster firing at the perfect time.
So this is the command trailer. We're able to control our test stand, which enables us to vary our set pressures, our flow rates into the thruster in order to collect performance data at various OFs and chamber pressure conditions. It's always a blast to come out here, set everything up, and start lighting rockets off.
Behind us, we have the carbon dioxide removal subassembly.
We're going to be creating the most integrated ecosystem that has ever been put into space thus far, which is a really cool thing to be able to say.
I fabricate PC boards and cables and harnessing. This is a life-critical job, and you want to make sure you do the best possible job.
"15 to 20 years from now, we're going to be surrounded by objects that we can't imagine how we live without, that were manufactured in space." I think there's another promise too, and that's why I'm really excited about the AX2 crew. There is this effect that people have gone to space and had. This is called the overview effect. Many people have come back profoundly changed because of their experience. And I think the more people that we can have that see the world as the whole world, the better off we all are.